I expect you to know some. Over 200, look at me. Did you score 0 over 200? It's okay to score 0 over 200. But don't try to score that in the main exam. So, please. So what you are going to do is that you are going to go through the questions. Any parts that you did not understand. And irrespective of how simple it is, don't be bothered about my friend. I think that Olodo is your friend's problem. So look at the questions. If there's any, that's the purpose of today. We want to use it to touch everything. So if there's anyone who felt like, oh, I felt the answer should be this. Why is the answer this? Or you really did not understand how we got the answer. That's the purpose. So look at everything, and to those that are online too, they can get from you indirectly. Because, and they can leave comments too if there's any question they do not understand. Those that did it online. So you can just let me know what number, what question you need clarity for. Number 60. 6. So, please, do we have extra questions that I can have? So that you can also use your question to follow through. So, number 6. They said that how many atoms are contained in 2 grams of hydrogen gas? I think I was one that taught you stoichiometry.
Yes.
And when I was teaching stoichiometry, I told you some things that when you hear atoms, when you hear molecules, you have to be careful. The question can be very simple, but you also have to be careful. How many atoms are contained in 2 grams of hydrogen gas? So you are talking about hydrogen gas, Abby. So the first thing you do is find the number of mole. That will be mass over the molar mass. And remember, how many atoms, how many moles of the atoms are present in 1 molecule of hydrogen gas? There are 2 moles of the atoms. In hydrogen gas, how many atoms do you have? How many atoms in hydrogen gas? 1 mole of hydrogen gas. That will be 2 atoms, Abby. So now when you calculate the number of moles, then you remember you have 2 of it. What the number of moles you have calculated is in terms of the molecules. Do you get the point now? Is there anybody that is confusing to? Let me explain it to you. We can rock the board now. Why? She be the advance. We are be fast. But to those that have phones are not better. Avoid my head. Where's the first line? Please, your name again. Desiree. What did you say her name is? Elizabeth. What's her name? Your name? Miriam, the girl that you have a look at your river Joshi. Miriam, the girl at your back. Look what? NJ. Heritage. Okay, heritage. So heritage, do you understand now? I want to solve it on the board for the sake of everybody.
Don't start. Maybe me.
So sometimes questions can look simple in chemistry.
I know that it's atoms, so I choose for 0 to read them. Number 25. What's the answer? Number 25. I think, Yeah, you have said that.
What do you be?
It just, and it should be different.
When you see a question like this, you pick the triangle.
Let's try it.
But it should be trigonal theorem. So, they said that number of mole of hydrogen gas, that would be mass over molar mass. And the mass is 2 habitants. And 2, that's 1 mole. But remember, what you have calculated here is 1 mole of hydrogen gas. I mean, heritage, are you looking up? What we have calculated here is 1 mole of hydrogen gas. In 1 mole of hydrogen gas, how many atoms? Just like the way I told you the last, when I was explaining that, I remember, I told you that if you are saying 1 mole of a pregnant woman, and the pregnant woman has 2 children, so the number, if I now say what is the total number of children in that woman, are you going to say 1 times 6.20? You are going to say 2. 1 dozen is 12. That means that out of that 1 dozen now you multiply it times 12, whatever it is. So there are 2 hydrogen atoms. But if they had said number of molecules, you will use the 1 mole. But now, how many atoms do we have here? 2. That means in 1 mole of hydrogen gas, there are 2 atoms. So in that 1 mole, and 1 mole is supposed to be 6.02 times 10 raised to power 23. But now you have 2 atoms. That means this will be multiplied by 2 to give you the total number of atoms. Do you get the point? So, but you could have just done it this way. Probably 2 will give me 2H plus Sabi. So 1 mole will give me 2 mole of hydrogen atoms. In a way. And just putting it on to split it. And if 2 moles, that means 1 mole will be 2 moles. And number of moles is number of particles over. So if this one is 1 mole that we have gotten, this one will be what? 2 moles. Then we can say number of atoms is going to be the number of mole of the atoms, there are 2 of them, multiplied by the Avogadro's constant. And that's 2 times. So it's complementary. Those are the little things you have to be careful of. Number 1 and 2. Hello. Everybody, what's the answer to number 1?
B.
In electrovalency, most metallic atoms with few valence electrons give out electrons because they said most metallic atoms, they give out their electron. Why? It's because they have low ionization energy. Number A is saying that because they are unstable. Is there every atom that's why in the exam you have to be very careful. Is there every atom that is unstable that give out electron? That's the question you will ask yourself. They were specific. They said most metallic atoms give out electrons, Abi. But if you look at all the atoms, the non-metals, they accept electrons, Abi. They now said that why is it that they give it out easily? All because what? They require less energy to give those electrons. And that's why they give it. They are not accepting. If you are unstable, you can either give or accept. Why did they choose to give? Because the energy to remove it is less. So they prefer to give because there's less energy. So you have to carefully pick some answers and ask yourself questions before you pick the answer. Please, do we get that point? So, then number 2. What's the answer to number 2?
Hydrogen bond. Hydrogen bond.
If you are not careful too, you can pick covalence. You have to be careful. The only statement that made it hydrogen bond is that word molecules. It's molecules that made it hydrogen bond. They said that bond between the highly electronegative atom, forget that statement. That one can be to covalent, it can be polar, it can be non-polar, depending. It can even be ionic for the word electronegative. Then, between a highly electronegative and the hydrogen atom from another molecule. Hydrogen atom from another molecule. So if this is a highly electronegative element, let me just say this is nitrogen. Then hydrogen from another molecule, let's say water. If these guys are meeting, I'm just using it as this is a molecule. They didn't say hydrogen atom. If it is a highly electronegative element and hydrogen atom, and they are not specific, but if they are still specific, even they will be specific, they will say molecule if it is going to be hydrogen bond. But when I taught you, I said, was I the one that teach you? I thought I was the one that even taught you chemical bonding. I said there's a bond between atoms, and there are bonds between molecules. The bonds between atoms are the interatomic bond. Those ones are the ionic, covalent, and all. But the ones between molecules are the van der Waals forces and hydrogen bonds. So now they are now saying between the highly electronegative element and hydrogen molecule. So this is a molecule. So if this guy is interacting with any electronegative, and you remember hydrogen to nitrogen, hydrogen to oxygen, hydrogen to chlorine, that represents what? Hydrogen bond. So to score 90 something to in chemistry, you have to also be smart. Some questions are direct, but some questions you have to be careful. And you don't have to be too careful, Nessie. You don't have to be too careful. Is that thinking? So what question next? So do we all agree that the answer to that question is hydrogen? Number 4. There are some questions that you don't need to solve in an example. When it comes to pressure law and Boyle's law, what's Boyle's law? What your brother, the noise is much. Is that it? You remember Boyle's law? Boyle's law is V is inversely related to P. Meaning that if you double P, this one will reduce by 2. If you double this will reduce by 2. So if P1 is 200 and P1 is 100, so to say, and if P2 is 400, then that means that this P2 is going to be what? 50, not 200. If this one double, this one reduced by 2. That's what it means. So it's not everything you solve in the example. So if this one is half, what will happen to this? This one will double. Abi, so by reduce the name by 2, the name will double by 2. It's not everything you have to solve in the example to be smart ones. But now, let's look at it. They said that what will be the new volume? V2. If the new pressure is half, so half P1. So let's say V1 is V, and P2 is half P1. So P1 is P. So if you have the new pressure, what will happen to this? They are inversely related. This will double. To reduce the name are double. It is smart. I hope you are ready for the exam.
No.
Some of you, you think it's magic. You always think the exam is magic. And there's a stage you have to get to that you have to really be smart. There's a level of preparation and there's a level of being smart in the exam. And everybody is smart, but your preparation will lead to your being smart. Your preparation will lead to it. So if you don't study hard, that's why some of you, I don't know, you read like crayfish. I read like that one that came to report JP to me then that he was reading 1 hour and JP was forcing him to read hours. That he's not used to reading. I just looked at him. You are reading 1 hour in a day. And you are saying that they are forcing you to read hours. What are you reading? You read 1 hour, you are happy. You want to come work back? Oh, think 8 hours in a day. But I understand that maybe it's just learning and it's just starting. Some of you will read 2 hours and you'll be like you have read the whole world. So don't beat yourself up. Don't beat yourself up. Oh, take out. You are just trying. Oh, take out. So just read. Just try to work harder. So, because there's a level that your smartness will be required more than what you have read. So let's solve it. So if P2 is 1 over 2 P1, what do you think will happen? That means that you can say your V1 P1 is equal to V2 P2. Abi, your V1 is V. Then now say what is V2? Your P1 is P. Abi, then your V2 is what you are looking for. Then your P2 is P1 over half of P1. Abi. So that means that that's P1 over 2, right? So if you cross multiply, that means this is going to be 2VP or 2V1 P1. Abi, you remember what was V1 P1 will be equal to V2 P2. Sure you get. So your P2 is that. Is that P2?
Yes.
Okay.
P2 is half P1.
They said the new pressure is up, so your P2 irrespective. This is your P2. Whatever it is P over 2. So if you look at the option, there's none of them that actually have P1. Abi? So which means we still have to work with this. This is V1. So in our option it says V1 P1. Abi? That's what we have here. Equals V2.
They said P2 is out.
This should actually be like your P1.
They said P2 is out. When you say P1 is out, they said P2 is out. Should be P2 over 2.
P2 is half of P1.
Yes.
No, they said P2 is out. Should be P2 over 2. New pressure is out.
It's not it now.
Oh.
It's correct. It's just that P1 will be 2 P2. It's
If the
correct.
new pressure is out,
Yeah. That is P2 is
That
out.
will be P1 is equal to 1 over 2 P2 over P2.
That is what it is.
And now we're going to do it inside.
wait.
It was multiplied.
And now,
A and D.
what you did initially.
A and D is the
That
same
is
thing.
P2. If the new pressure is out, okay, they did say of P1. If the new pressure is out, so you don't know that's half P2. Yes, that's correct. So that means this will be P2. Do we understand that? So your P2, they did say if the first pressure is out, they said that if the
If it was
new,
multiplied,
P1,
where is it?
P2 over 2.
If the new pressure is out and the initial pressure remains the same, so P2 is the one that is out, while P1 remains P1. So that means that we can say that P1 P1 is equal to P2 P2. But what happens to P2? You have reduced it by 2. So in that case now, this is going to be P2 over 2. That's correct. Should be? So now we can say 2V1 P1 is equal to
P2.
V2.
Yes. Let's move forward.
If you look at why you should not pick D, D looks like V2 over 2. V2 over 2. If it's together, you see that when it's together, they put it in brackets. So farabalẹ̀. So the best option to pick there is option A. Do you get that? Number 7. I know a lot of you missed that number 7. 10 cm cube of hydrogen gas were sparked with 20 cm cube of oxygen. What is what's the answer to number 7?
15.
15. If you did not see the word after cooling, to rush, you will miss it. You will pick 25, and that will be wrong. So please, sometimes your exam will be very simple. Hello? Are you with me? Your exam will be very simple. But when we give you mock, we are using mock to train you, to train your mind. Some of you will rush to answers. That's what number 7 is teaching you. That when you see something, carefully look at it. They said that if 10 cm cube of hydrogen, some of you immediately see 10 cm cube of hydrogen and 20 cm cube of play volume, you just go on. Because you are smart, so come. So just said 282 plus O2 to give me 282. There is a if 10 cm cube of hydrogen was packed with 20 cm cube of, and you can see that this one is 2:1, Abby. You can't use this 20, you remember. So if this is 10, this will be 5, and this will be 10, Abby. So at the end, what will you have left? You are going to have nothing left for this. You are going to have 15 left for this, and you are going to produce 10. Now, you will just say, my answer is even option A, 25 cm cube. That's the total volume left. But read the final statement before you say that's your answer. The final statement says that after cooling. What does cooling mean? What do you think cooling will do here?
Remove water.
It's like I will leave this class. I will not do it. I'm scared for all of you. I will leave this class. I don't want to go home sad. I don't want to go home sad. Because if I'm asking you by this time some things and you cannot answer me, no. Last year I told them that they were the worst sets we've ever had. I told my students in class that they were the worst sets. Because, and those ones were still serious. But I saw some evidences of level of seriousness. But for what's really worse. If there is worse, was our worst sense. This one is worse sense. There are some simple things that immediately I mention it, I expect you to just give me the answer or give me response. I understand that you might make mistake. A lot of you might miss it. That's the purpose of the mock. It is just for you to learn. But if I'm not asking you basic questions and you are still looking at me like the chicken you ate for Christmas, look at this. When they said that I'm cooling, what will cooling do?
Number 16.
Some of my
16. Okay. 16.
I have a lot
It's
to
on through that makes
God help all of you.
Yes, it's on through now.
So I think what is left to do with is prayer.
Arrange it now.
Like when it's not
You
fitting.
just have to pray for it. You cannot be
Cannot be about
you will make me sad for like 1 week.
That's
So
right.
it's better I avoid
Why one?
If you lower the temperature, you know there be roundabout. Wọ́n ṣe sí sọ́nà Ìbàdàn yẹn. Ṣé Lútọ̀ ló fẹ́ ṣe lájú àgbà?
So you chose that back.
To lower the temperature. So when the temperature is lower, what we now? What is the difference here? When I taught you this part myself, so you can't tell me that it's a teacher that didn't teach you. You can't tell me. I taught you the research stuff, and I gave you some conditions. I said if it is at room temperature, anything liquid, you remove it. You only give it gases. Did I not teach you? There's every evidence that you have been reading. If you cool it, you are cooling. What does cooling do? It will make the gas, which is the steam, it will turn it to water. And the moment it turns to water, you can't add it again. You only deal with gases. So that means this one cannot be part of your answer again because of that word cooling. Please, to those of you that have read, do you understand that? The purpose of mock is to just... I'm not giving you mock because I think you have not read. We are giving you mock because we know you know it. Then we are now setting traps that you might likely fall for in the exams. So that when you see this now, we correct... This moment is to correct every form of abnormalities. Teach you how to solve questions very fast, time management, everything. So that when you get to exam more, you saw a lot of them that had 98 plus last year in primers. A lot of them. So there's nothing in all of these things if you are just big. And these questions are from your books. Question what's next?
25.
25. Question 8. The closer the molecules are, the liquids, the closer the molecules of the gas are in the liquid states. So what's the answer? A, the more accurately to follow the ideal gas. Does it still follow the ideal gas? What are the conditions for ideal gas?
High temperature and low pressure.
What are the conditions for ideal behavior?
High temperature and low pressure.
If you decide not to answer me again for next 2 questions, I'm walking out of your class. I will pray for you in my heart. There are some questions I cannot be asking you and you will not answer me immediately. There was a year when you used to write post-UTME. I used to take, then it used to be physical. So I would be the one to take all our students to Ife. Then we might be there for like 2 days. While those that will write today, next tomorrow. So to finish the post-UTME and come back to Ibadan when we were still doing physical. And there is a tutorial in Ife that I used to teach them when I was in Wales. But since I came to Ibadan, I used to go there to teach. But the traveling every week was not that easy for me again. So I stopped. But what they would always do is that when it's like 2 days to their exam, they will call me to come. So we used to do some marathon. So I would teach them from morning till night. Then I would teach them overnight. So in one day, I would cover several topics in one single day. So, and at the end, we will give them questions and exam. But when I took all my students along, when we went for post-UTME some days before, just looking at the class that they wanted to do overnight, we realized that all the students over there, they did not know anything. I just asked my students to go and sleep because it will waste their time at the end of the day because I asked them to join. Now, immediately I ask my student a question, everybody is responding. And it will get to a stage that you just know everybody they would have been so smart that that's how this stage is always like. You might still have some bit of, I understand, but during post-UTME, we don't always even have that. Immediately I ask you something, you give me the answer back. That's during post-UTME because during JAM, you have been trained. So during post-UTME, the people that used to make us to go and teach all the topics from beginning again during post-UTME is because of those that used to come and join. That just joined us during post-UTME. So please, as much as possible, there are some questions that immediately I ask you, I expect a chorus answer. I don't even expect everybody to keep quiet. And nobody should form anything here. If you know it, speak out. Don't say, let me keep it to myself. So please, because the moment you are not answering me, you are influencing me small. And I'm not happy about it. So it's not because you are not answering me, but it's because you are looking down. That is influencing me. And I don't want to see you look down. And that is the anointing. So A is wrong, Abi. And you know why A is wrong? Because it has deviated from ideality. It has become a liquid. The fact that they are even getting closer, it means that the temperature has dropped, Abi, and the pressure might have increased to some extent. So the more it will deviate from ideal gas equation, you see that A and B are still saying the same thing. Even if you don't know the answer, A and B are still saying the same thing. That's how you do it in the exam. Option C. I mean, B is saying opposite to A, Abi, but let's look at it. C. The more random is the movement of the gas, is that possible? Then D. The more kinetic energy you have, is that possible? E. The greater its pressure it exerts on the walls of the container. Walls of the container inside the vessel, is that possible?
No.
So the best answer is option B. Is that taken? Yes. But at what condition do you have ideal behavior? At high temperature and low pressure. At what condition do you have real behavior? Low temperature. So all these are things that should just be part of you, normal. That if you see them in the exam, they are bonus. They are bonuses to you. I remember I talked about them in my class. And you would have seen questions of them. Number 30. So from, I will answer 25. Number 30. From the first law of thermodynamics. So please, latest by 5. I will leave. So we are spending 2 hours. So you can continue to ask your own questions. And if you feel your house is very far and you cannot be part of it, or you are tired, the thing is that we are doing general revisions in chemistry. That's what we are doing. So that when you get to exam on Saturday, you can still use some idea and logic to do it. So, but if you feel your house is far, you are hungry, you want to faint, the baby inside you is kicking, you can gently just sleep. Don't cause disruption. So 25, 30 first. From the first law of thermodynamics. Now, first law of thermodynamics states that thermochemistry comes.
No, that is what is next. Chemical. Ah, it's deep, but it's I don't know that. But it's deep. I don't know that it's just no. But now I know.
So from the first law of thermodynamics, you already given delta U is equal to Q plus W. Now you might not need to bother yourself too much about this thing. You need to know it for that purpose. But there's a phase we look at this thing in physics, and there's a way we look at it in chemistry. But the question you asked here is very simple. They said that this is the first law of thermodynamics. This is the first law. This delta U, you can see it. So they used to give the equation in your jam and say what does it represent. Now this delta U, we call it internal energy. Internal energy. That's the energy possessed by the whole system. You have gases. You gases are present here. So there is internal energy. There is total energy possessed by those gases in a container. That's internal energy. But what gives that energy? One, is it taking it from the environment, or is it releasing it to the environment? And you all know what's taking it from the environment means endothermy. I mean, giving it to the environment, exothermy. So these Q parts represents this part. So Q can either add to the energy or take away from the energy. So what determines the total energy possessed by these guys is these two guys. One, the amount of heat you supply or the ones you remove. Two, secondly, the work you either do on the system or the work the system does outside. You can do work on a system by pushing the gases together, compression. So if you have a piston, you know you can push this thing. When you push it down, you can change the volume. So it has a bigger volume, so you can change the volume. So the change in volume can now be probably V2 minus V1 for the change in volume. Now, what is work done? You remember, was it pressure? I think, let me do something first. Pressure is equal to force over area, right? Work done is equal to force times distance. If this will work, then this is going to be work done over area times distance. This is what pressure I mean. So that means that my work done can be equal to pressure times area. And what's area times distance? Like length times breadth times height. That is what? Volume. Volume is equal to area times whatever length. Shady? So that means that this one can also be pressure times volume. So that means work done here is pressure and volume. So if you keep pressure constant and you change volume, that means that your work done will eventually be equal to P dV. So that means from here I can take this guy and say that this equation becomes Q plus P dV. That's what they're asking you. Yes, for gases. You can change the volume and pressure and everything. So, is that taken now? So that's how we got the answer. So the answer there is option D. Is that taken? So 25. Have you done E0 of a cell?
Yes.
What is E0 of a cell? The total work done. The total work done. E0 of a cell is E0 right minus E0 left.
Yes. Yes. It's different.
Now, they said algebraic products, algebraic sum between the electric potentials of the electrons, algebraic zero, algebraic difference between the electric potentials of the electrons. Now, when E is positive, will that be spontaneous or non-spontaneous?
Spontaneous.
Do you remember this formula?
Yes.
That's E0 right minus E0 left. Now, E0 right is the potential. It is going to be spontaneous. Let's say that the E0 of zinc. What's that E0 of zinc? I think it's 0.764. And the E0 of copper in the reduced states. That is minus 0.34 volts. Abi? Now, if I want to do my calculations, I'm going to say that the E naught of the cell, I want us to be careful before you take answer here, is going to be E naught right minus E naught left. But your E naught right, that is going to be zinc, Abi, and is the one in the oxidized state. That's 0.76 minus so
you want to change the side.
it's the fact that the word algebraic sum, all those signs we are seeing, the signs, you don't understand this that I've done.
0.76 should be minus.
You know this? This particle, you don't understand. You know this formula. And why don't you now understand this?
So 0.76 should be negative because it's in oxidation potential.
Oh, sorry. I said both of them must be their reduction potential. No, it's correct now. Is that okay now? Do you understand this? Is that the problem? Don't say you don't understand. Say that there is a mistake. You don't, you have to, you know what you are doing. Anybody can make mistakes, so don't make it look like you are the one that is wrong. You should be sure. You know that, okay, I made a mistake here. Instead of you to say that, oh, sir, there's a mistake, that shows that you know it. But the moment you now say you don't understand, that means you still believe so much in what I'm saying. That maybe this thing is, what I've done here is right, or because I'm your teacher. Be convinced yourself. You already know how to do it, so you must have seen that, oh, I made a mistake. So you just call my attention to it. That's what you should do to any teacher. It's not like in a rude way, but, sir, I think the way we are supposed to do it is this. But maybe there's another method, I don't know. This is what should have been the answer. But this should have carried negative. The teacher will look at, oh, sorry, I made a mistake. Then that shows you know it. So you are speaking to your mind. But the moment you're having a belief behind, you start making you feel like, I don't know which motivation without a job. Do you get my points? So anybody can make a mistake. Don't say because your teacher is wrong. So that's what we have here. But I hope I've corrected myself now. So the answer is 1.10. Now, the word algebraic sum comes from the major reason we have all this negative and positive is it depends on the one that is donating electron. The ones that donate electrons to hydrogen, they are usually given negative reduction. I mean, is that negative? Yes, they are given positive reduction potentials. The ones that take electron from, let's say this is hydrogen now. The ones that give electrons to hydrogen, they are given positive reduction potentials. The ones that take electron from hydrogen, they are given negative potential. So what indicates the signs, positive or negative, depends on which is given or which is not. But if you look at it, every time you calculate potential, it is always a value of the first one plus the second one in total. The signs are just indications of what is happening. The 1.10 we have here is the total value for both of them. Is the sum of the potential for individual electrode. I don't know if you're seeing what I'm saying. 1.10 that we have here, it's an additional value of E naught of zinc and E naught of copper. Yes, according to the formula, E naught right minus E naught left. But they said the value. The electromotive force, that is the EMF, the EMF of an electrochemical cell is given by
the difference.
So let's be careful, Sha. Let's look at this. I want to agree with you to some extent, but there's something in my mind that is saying that because every time you calculate EMF of a cell, you know I can use another formula. There's a formula that says that E naught of the cell is equal to E naught right plus E naught left plus, and that is S law. So S law states that you will sum everything together. But now, the difference between S law is that one has to be in its oxidation state and one has to be in its reduction state, normal thing. But in order to get the total EMF, you have to sum everything together. And that's the only way. So for now, please start that question. But for now, the answer is sum of it, not the difference. Start that question. The formula.
Have you recorded the question about
Look at it's just the same thing I just explained that I also explained. Now look at it. You can still question this like too. He said that the electromotive force often denoted as E cell is the maximum potential difference between the two electrodes of a cell when no current is flowing. That is what we have here. Now, is the maximum potential difference. It is calculated by finding the difference. What's the maximum potential difference here? It is calculated. It is calculated by finding the difference between the reduction potential of the cathode and the anode. This one is here an explanation. That's how we calculate it. We find the difference. But now, in this context, it represents your degree between the difference between the potential of the two half cells. While some sources might refer it to as the sum if they are specifically adding an oxidation potential. Now, according to S law gives that it is the sum. But now, in that case, we had. But if you look at the two values, it does not look like 0.76 minus 0.34. Forget the signs between them now. Every time you calculate E naught potential, it is always addition of the two values we get as your answer. I don't know if you are getting my point. You will always get addition of the two values, irrespective of the signs you use. You will always get, look at the answer we got here, 1.10. So, if the sign we have here is just an indication of what is happening, but at the end of the day, your final answer shows the potential for both zinc and, I don't know if you are getting it, but if you want to look at it and say that, oh, it is the difference, do you know that I can get negative here? If I get negative, what is it telling me? I've done the arrangements in the wrong manner. So the total EMF should be what both of the metals are doing in that electrolyte. So it should be a total value for both of them. And if you use S-law says that irrespective of the direction, the summation will always be the same. So all of these signs you are seeing, they are just indicating some things. So in some contexts, the sum will be correct. In some other contexts, the difference will be correct. If I want to think about it, be flexible. But sometimes in the exam, it is the examiner that can tell you which one I'm thinking about. Then another thing you can do is that, do you have a Babylon? Oh yeah, let's look at page of EMF on a Babylon. It is whatever that one says that you will take in your exam. Even AI too is explaining the two, that the answer could have been this, or the answer could have been this. So it depends on the context of the textbook. But for me, if I'm to reason it, copper is 0.34, zinc is 0.76. My final EMF of the cell is 1.10. So what does that mean? That means the two values have been added. So yeah, have you seen it? Give me the textbook, let me quickly check. So this is one of the things we do at this time. Verification, confirmation. The only way you can score 100 is when you argue, have perfect understanding. It's not just a bunch of sunny and go move on. Nobody's, if I write my own textbook, I can say it's the song and give reasons why I said it's the song, and I was able to prove it. But this is the textbook recommended by JAM that you all should read. So whatever my opinion is off. If what this guy says is different. But if there is nothing about this guy, then we have to read some other textbooks. Yes, there are several textbooks recommended, not just one. So, let me look for...
I'm not very Listen. Have you collected your... What do you get? Come on, what do you get?
Okay, the facts of electric potential, the standard electric potential, measuring the electric potential. So, the definition is there. Now, let's look at that part of the EMF. They said that here the standard that when the copper system was cell, the voltmeter shows a reading of 0.34. This is the potential difference between the two half cells, and it's known as the electromotive force of the cell. As the electrical potential of hydrogen, the standard electrode, the half cell reaction and copper hydrogen, the electrical potential of voltmeter reflects the effects. For comparing electric potential values of the standard
I know this is not what I get.
So let's read the question again. Question what? So let's look at it again. I think what is making this question is that statement algebraic sum. The word algebraic sum means algebraic sum does not consider. If I say, look at this. If I say, please, the answer is actually addition. I will read something out to you. Now listen to this. If I say that in physics, a boy walks 3 kilometers south and 2 kilometers west, 2 kilometers west, and then, or let me say 3 kilometers south, 2 kilometers west. What is the algebraic sum of the distance? Whenever you hear the word algebraic sum, it's talking about scalar. More like a scalar quantity. You don't consider directions again. You don't consider in the signs. In this case now, I'm going to get the values by algebraic sum, the scalar. If I want to calculate distance, my distance here is going to be what? 5 kilometers. I mean, I don't care about however it moves. Anytime it is scalar, I have to do the algebraic sum. I mean, algebraic sum. An algebraic sum simply means addition of all of the values without considering directions or the signs. Now, listen to what Abado says, and note that it is still different from the question. The question says that EMF of an electrochemical cell is given by A, algebraic product between the electric potentials of the electrodes. B, algebraic difference between the electric potential of the electrode. C, algebraic sum between the electric potentials of the electrodes. Now listen. This is the potential difference. Potential difference does not mean the algebraic difference. The potential difference is the one for each electrode. It is the definition. I don't know if you are getting my point. If you go to that of hydrogen, if you read from here to here and carefully analyze, you will see that we got to look at the point here. This is for comparing electropotential values different metals, ions, the standard electrode is used. This is the potential difference set up. If I ask you now, what is the potential difference set up between copper and zinc here? What's the potential difference set up? 1.10. Is that the difference between 0.74 and 0.34? But the potential difference is the EMF. It's not the algebraic. I don't know if you are getting my point. So the potential difference is say 1.10. But the potential difference for zinc is 0.74. The potential difference for copper is 0.34. Putting everything in consideration the way it should go normally, it is the sum of those two values that will give us the EMF of the cell. Do you get the point? Read it carefully and go through it. If you now look at that of hydrogen, they now told us why one has negative and one has positive. So they said hydrogen has been chosen internationally as an arbitrary standard. And they used to ask you this one exam. Now what is the value of that of hydrogen? 0.00 volts. The standard electrode potential of a given metal is then expressed in terms of the potential difference which exists between the metallic electrode and the standard hydrogen electrode. This is known as the standard electrode potential of the metal ions metal system. The electrode potential value is positive if electrons flow from, that's what I said here. It's positive if electron flows from the metal to hydrogen, and it is negative if electrons flow from the hydrogen. It is negative.
No.
Wait. The electron potential value is that of zinc is negative. Is it? Okay, yes, it will undergo oxidation. So that means this statement is, please, I wish that, how many of you know all these things we are saying? That's why I always wish a moment like this, all of you have been smart. Because you don't know how painful it is when you want to have an intellectual conversation and the next person you are conversing with is just looking like this. You don't know how, I don't know how it sounds. At this level now, what we should be having is intellectual conversation. That's what we should be having now. When you started learning, when you started reading, it's okay. And we come down to your level. But after I've taught you something, okay, I think you said you have not done this topic. Yes. So, this is supposed to be negative. This is supposed to be positive. But because all of you are just like this now, you cannot even follow me. So even as my brain is thinking that your brain should be supporting it, the reason this one is positive here is because it is in a reduction phase. But if I flip this, it will become negative. And if you arrange them from top, zinc will come before hydrogen. The ones above will donate electrons to hydrogen, while the ones below will take electrons from hydrogen. So the ones above usually have negative reduction potential, while the ones below usually have positive reduction potential. Just an indication of the deflection of the what's it called. So please, if you calculate it not negative, that's just the indication. That shows that you have put a metal where it's not supposed to be. In this setup now, the metal should be at the anode, that is zinc. The copper should be at the cathode, because it is the zinc that can give electron to copper. But now, if you put copper at the anode and put zinc, then this value will show you negative. But it's still the sum of the two values you have, but it will be negative. But at the end of the day, if it is negative, it's telling you that what you have done is wrong. Rearrange it. That's what it's showing. So please, convince yourself. The only thing, yes. Yes. No, it's still the sum. The negative is just an indication of is it going to be spontaneous? That means that what you have arranged, is it correct or is not correct? So is it going to be spontaneous? What we got here now is positive. That shows that it is spontaneous. That means that what that is just saying is that if you look at your cell, you have anode and you have what? Cathode. The one that should be at the anode should be the one that can donate electron, because there's electron loss at the anode. Now, if you now put copper here and you put zinc here, you will see a deflection to the left, showing you that this guy is the one sending electron, but that is wrong. Zinc should be the one that should be here. So this side, if you get positive, that means that you have done perfect arrangement. Zinc is here, copper is here. But if you get negative, that means you have put copper here and zinc is here, so you have to change the settings. That's why if you get positive, you say yes, it is spontaneous. If you get negative, you say no, it is not spontaneous. You have to rearrange the cell. So let's leave that. That's my own answer for now. I still stand to face court of appeal. 29. The answer is B. What's producer gas? nitrogen and CO. Then they said that it bonds with a low heating power because of the nitrogen that is present. That's why it bonds with a low heating power. The nitrogen is acting as diluent for the CO. It's the same thing we talked about in oxygen and nitrogen when you study here.
Yes.
Do you understand that? That's the answer. 33. The number of moles are equal for 39. 33 abi. Is it 39 or 33? The number of moles are equal for the gases. So pressure will have no effect. That's a very simple question. 29. Substances which dissolve endothermically. If something is endothermic, what will happen? You need to supply more heat because it's taking it. So you have to continue to give it more heat. So that's at high temperature. Do we understand that?
Which number
18. What do promoters do? Number 18, promoters.
This one does not have plus and minus. I was not thinking it's this one.
They just make the catalyst work better. There are two types of catalytic process. We have the promoters. Promoters enhances the function of the catalyst.
I'm not proud of myself.
Then we have inhibitors. Inhibitors resist the function of the catalyst. So the answer is enhances. 32. What happens if the temperature of the system decreases? Have you done chemical equilibrium?
No. But the answer is that.
So what will happen if before your main exam you will do all these topics that you want to do during your immediately you come back from your mock exam or something. So in case you don't have ideas before. So what did you say? 32.
Yes.
They said that if the temperature is decreased, the forward reaction is exothermic, and the reverse is going to be endothermic. So the one that is exothermic, you want to decrease the temperature. So if you decrease the temperature, you favor the forward reaction. Because it is exothermic, so we got to reduce temperature. That's it. Forward reaction, that's the right side. A plus B to give C, delta H is negative for an equilibrium process. In this case now, this guy is exothermic, and the fact that it's exothermic means that it's hot. The forward reaction is exothermic, the reverse will be endothermic. Anytime you see that forward is exothermic, the reverse is endothermic. And this forward is exothermic, it means it is giving heat to the environment. So in order to favor it, reduce the temperature. So in order to favor products, reduce the temperature. But if you want to favor the reverse, then you have to increase the temperature. Because if this one is exothermic, this one is what? Endothermic. Reverse is endothermic, if forward is exothermic. So decreased temperature will favor exothermic parts. Increasing temperature will favor endothermic parts. That's just a statement you should note. When you reduce temperature, you favor exothermic parts. When you increase temperature, you favor the endothermic parts. So it now matters which one is exothermic, which one is endothermic. 39. 38. Because the nuclear energy you produce is by converting your mass defects to the energy. Abi now?
Yes.
Einstein equation.
Yes.
E is equal to mc squared. So the mass effect is converted to energy. That's the answer. Good at math to mind the point.
200.
39.
Abasa 16. Close one. 44. No, get the right one.
I know it's alright. Like, what I try is similar. And probably see to the AC I don't know.
29. 44.
I don't say it before. I need to.
When you expose chlorine water to air, to sunlight, what do you produce?
ACL and oxygen.
HCl and oxygen. This is chlorine water. When you expose it to sunlight, you get HCl and oxygen. Next question. 39. 39. They said that the one that decay. So your answer should be like 80-something.5. Look at what you have here. They said that the original mass was 100 and the half-life was 5 days. After 5 days, what would this one have become? I saw when the friend was using all the passion to teach you that day. So you can't be like a after 5 days again, what would be left? 25. Then after 25 days, after another 5 days. So after 15 days, what you have left will be 12.5. But what would have decayed is the question. That would be 100 minus 12.5. That means that's 87. So it's not the option. But in the exam, you don't leave it like that. If you meet something like that in JAM, your answer is going to be 12.5 because they might want to ask you what was left and they make mistake like decay. And since you did not get your decay in the option, it's better you pick that of left. Do you understand that logic? It's not everything you do. 60. Question 60. What does it contravene? Polar exclusion principle. Sorry, the answer is on you. The answer is on you. It's on you. Number 60 is on you. You have to share electrons singly before you start the electron. Is that taking? No, when I was doing the solution, I also miss it for me. So I was getting tired already during the midnight.
So I've got too much to say.
So, but before we said it. Number 9. You will pick PO, lower the freezing points of sodium chloride because it's going to, both of them will serve as impurity, however. So ice will be an impurity to sodium chloride will be an impurity to ice. So the best answer there to pick is 2. Next question. 66. A saturated solution at 30 degrees Celsius, when will it produce crystal? At a temperature lower. So that's 20 degrees Celsius. When you start reducing it from 30, then you start forming crystals. Is that taken? Please, it is not everybody that will score 200 and above. It's not everybody that will score 200 and above. Don't compare yourself to anybody. Some people might be complaining they are tired, they are leaving. Everything you are doing, they are not even listening. Those of you that are listening and are learning, please continue to enjoy. One of you that will do the same, have the same score. 69. The answer is B. Bromine water and acidified magnesium. That's the normal test. Is that 26? 26. You should know this one. Calcium chloride. When you carry out calcium chloride, what will you use? Chlorine and calcium and you know why it is chlorine? Because it is concentrated. That's why it is chlorine. I mean hydrogen gas. Chlorine and hydrogen gas are the ones that will be released to. Is that taking? It's chlorine and hydrogen gas. Hydrogen gas is below calcium and it's far. If you were in Samuel class, you will remember that. Chlorine is below, I mean above hydroxy. But because chlorine is more concentrated and it is not that far, then it will be chlorine that will be discharged. Next question. 100. 100. The rate equation for the chemical reaction above is, what is the overall order? If you are not done chemical, that means you are not done chemical kinetics. All these are important topics, so if you can even find somewhere to read them before your mom, try to read them. If you are writing up on Saturday, read them. There's no way you will tell me that you will not see questions on chemical equilibrium, chemical kinetics, thermochemistry, and electrochemistry. You cannot come out of your work. You will definitely see questions there. You will see questions there. If you do not see questions there, come and collect your jam. Máa fún ẹ lówó jábẹ̀ gbogbo lẹ́sìn tó ti sọ látọ̀jọ́ ẹ̀. Ìrajà padà fún ẹ. Ìyẹn tó bá kọ́ ẹ̀sáàmù yẹn tó bá dé bẹ̀rẹ̀ mo wá rí pé ó sì kẹ́ òun ẹ̀kọ́ ẹ̀sáàmù rẹ̀ jáde máa fún ẹ lówó jábẹ̀. Bọ̀ tó bá kọ́ náà máa wọ̀ ọ́. So the answer is 3. That is third order, Abi. That is 2 plus 1, Abi. That's third order. 101. What question is next? 80. Question 80. In the reaction above, calculate the quantity of electricity required to discharge the zinc. How much of electricity will you need to discharge that zinc? If it is 1 mole, you will need 9,500. That means when it is half, then you will need half of 9,500. That means. Oh, is that 2 plus? Sorry. If it is 1 mole, then you need 2 times 1/8. You understand what I'm saying? Should I just use mouth to say it? No. The equation you are given is 1/2Zn2 plus 1 electron is just going to give 1 electron and it's going to give us 1/2Zn. Now, if it is this, there will be 2 electrons, Abi, and you are going to get 1 mole. 2 moles of electron will be required to discharge 1 mole, Abi, right? From here, actually, they have seen it. It's just 1 electron, Abi. We only need 1 electron now. So, how many moles of electron will be required to discharge 1/2 mole? one, but it's even here already. Shey you get? They said to discharge this zinc. How many zinc do you discharge? Half mole. How many electrons did you require to discharge the half mole? 1 electron. 1 mole of electron is equal to what? That's 9,500 coulombs of electricity. So that's the answer. That's option C. Abi? Please, we understand that. These are the likely questions they ask you in JAM on electrolysis. These are the likely questions. Don't be scared, but don't rush too much. Next question. 82. 82. That's a very simple question. It's Abi, I thought this one myself. Partial pressure of oxygen is 452. What the total pressure is this? What is the mole fraction? What's the formula for partial pressure? Partial pressure is equal to mole fraction times P total. And they said you calculate mole fraction. They gave you the partial pressure and they gave you P total. So just divide it. That's the answer.
Sorry, Ben said it's 82.
Online.
The one you did.
You said it's 82. The electronic configuration of X22, when you have X22, 2 plus, atomic number 20.
If it's that the alien is not in the question.
They now say the electronic configuration. What does the 2 plus mean?
That's not.
That's plus 2. So out of 22, what's left?
20.
So what would be the configuration?
That is the.
That's your answer. It's not there. Either is 3D2 is correct. It's correct. It's a transition element. Scooty, that's titanium. Abi. One thing you should know about transition elements is that whenever they are losing electron, you know if it is a transition element and it is X22, that means it's going to be 1s2, 2s2, 2p6, ps2, 3p6, 4s2, 3d2. That's the configuration. Transition elements. Whenever they are losing electron, anytime they want to lose electron, this is 3, 3, 3. So they lose this one first. It's not their 3D they lose first. They lose this one first. So meaning that if you even see this one in the option, and you also see this one, if you see this one, and you see this one, if you pick this one, you are wrong. If you pick this, you are lucky that this one is not even in the option. Because if you have chosen this, you would have been wrong. So far by the way example. I don't know if you are getting my point. The correct one is 3D2. They lose 4s first before 3D. Every time you see transition, it starts. So please, don't forget that. So if they want to make the, if I had seen this, I would have set the trap. Actually, they don't look at it too when I was setting it. If I had seen this, I would have put this one in the option, and I also put this in the option. And I know a lot of people do this. But you are lucky. So in this case now, even if it's an example, you will still pick this. You will not leave it like that. Even though your mind is saying, this one is the answer, but it's not the option, this and that. You shall know that your total number of electrons should be 20. And this one is showing 20. You pick that one. I don't think there's any other one showing up to 20. So that's why you are lucky. So that's why you will still pick D, however. But if the examiner wants to be deadly, you can put this in option and put this in option. And 90% of students will pick this. And you come out, and if they wake you up that, did you get this question, you say, even if they go and mark it in heaven, I got the answer. Yes, there are questions like that. So that's why you go out of the exam and start marking yourself. It's only the examiner that can mark you. I could have fallen into that trap too. Anybody could have. So let's just take our time. That's why you have to be cautious of time. As you are reading, read through quickly. Do your solution. But when you are picking answer, let the devil in your mind that is telling you that, there is that devil that will tell you, I don't know about me, wrong. Go there right. Sometimes just hold on. Because if it is right and something saying is wrong, it's probably the devil. But if it's right and something says is right, it's probably God that is telling you. So, but sometimes listen to that devil and check again so that the devil will not prevail. 85. In the diagram, why is a mixture of what? Have you done acid, base, and salt?
Yes.
So you should know the answer to that. Whenever you react ammonium salt with base, you get ammonia. Abi?
Yes.
So you react calcium hydroxide with ammonium salt. Any ammonium salt, you will liberate ammonia. So that's that. 88. All these are questions that I don't expect you to miss in the exam module. All these are still normal questions. Why is it that you are using hydrogen in oxy-hydrogen flame? Because it involves a lot of heat. Shake gets. It involves a lot of heat. All these are questions that you don't need to look at it twice now. Immediately you see it to pick the answer. 92. From the question above, it can be deduced that the heat content of the reaction is lower than that of the product. Is that correct? For you to have negative, that means that the heat content of the reactant is higher than the heat content of the product. When you do chemical kinetics and thermochemistry, my loves, they will teach you. The teachers will teach you.
115.
115.
Yes.
A solution containing chloride ions, this red precipitate to silver, will be insoluble in dilutes. In what now? What's the answer? It will be insoluble in ammonia.
Yes.
It's one of the ways you use to test for. It will be soluble in HCl and insoluble in. Is that correct? It will be soluble in HNO3 or soluble in ammonia. Yes, it will be soluble in HNO3 or soluble in ammonia. Is that taken? You can read that part again. It's in your inorganic chemistry. But let's. Yes, I think that option A is correct. Option A is correct.
You just with
46. For 46. I did this part in my video. Even there are a lot of these things I did in the video.
Yes.
If you watch that video, you will answer a lot of questions here. And those are questions you ask me. I did everything. Majority of these things, I explained them in that video that is up to like 20 minutes.
Yes.
I did that video.
I don't like any of this.
So if you watch it, you will be able to answer this. I said that sulfur is most viscous at what temperature? 200 degrees Celsius.
Yes.
It's a common question in JAM. Gbogbo kọ́lá ṣe kẹ́lẹ̀ pass. Wọ́n ṣe fún mi class àti wọ́n á tẹ̀lé lọ́wọ́.
93. Mama, I don't go out soon.
Oh yeah, let's solve one more.
M over I. Let's go first.
Yes, sir. She don't want to go back there. So one over. When the current I was passed through an electrolyte for 40 minutes. So the current was high. The time of passing it was 40 minutes times 60. Is that correct? When the current I was passed through an electrolyte for 40 minutes, a mass S gram of a univalent metal. So the mass of a univalent metal is X gram. Univalent metal means that, let me just use this one as an example. It means it's just one charge, just one. So at the end of the day, what mass of the metal will be deposited when the current of 2I. So now, what will be the mass if the current of 2I is now passed for 10 minutes?
Share your idea.
So that's what we have. When you have something like this, Q is equal to Z Abi. Since it's the same metal, the electrochemical equivalence, will still be the same. Abi, this guy, since it's the same metal, so Z will still be the same. So for this one, let's say this is X is equal to Z times I times equation 1. Abi, for the second one, we are looking for M. So we can still say M equals Z times 2I times. Do we get that? So we are using this formula. We use it for the first part and for the second part. So now we are looking for M. I told you anytime they are comparing two things, let your brain always think that something is common to them. So what is common to them is a constant. I mean, what's the constant? Z. So make Z here the subject of the formula and make Z here the subject of the formula and equate them. So the Z in equation 1 will be equal to the Z in equation 2. So I can say from here that from this place now, Z equation 1 is equal to X over I times 2/4. Do you agree? For this one I can say from here, Z equation 2 equals N over 1,200 Agree? So I can say Z equation 1 is the same, is a constant, is the same as Z equation 2. Then I can say my X over I 2/4 is equal to F over I and I can go. This and this can go. 12 here, 1, 12 here, 2. So So M is equal to X over 2 gram. Don't make mistake to go and cross again. So M is equal to X over 2 gram. That's your final answer. All these things are very simple, but you must have also been practicing questions. It's not just, I told you the last time I came, it is not just to teach you in class. It is not just to feel like I know this thing. It is the number of questions you can keep solving every opportunity you have. Just keep solving questions. And anyone you don't know, look for someone that understands it, let them explain it to you, then go back to solving questions. That's how you get better. Any other question?
116.
116. The oxide that remains unchanged when heated in hydrogen is what? I can't see option C. What's the answer? There's a part of this. Don't just be saying A. There's a part of inorganic chemistry that they gave some methods that hydrogen can reduce. When you go and study hydrogen and its compound. So, if you carefully look at it, the oxide that remains unchanged when heated in hydrogen. Even if you think about it, can nitrogen displace zinc? Open your Bible to hydrogen and its compound. If you have primaries in organic chemistry, open your primaries in organic to hydrogen and its compound. You will see the list of those metals that can be reduced by hydrogen. Hydrogen will remove the oxygen from them and those metals will be liberated. So even if you now do not know, the best answer should be zinc oxide. When you have you open primers in organic, when you have look at hydrogen and gas, there's a part of the actions of hydrogen. And that's question because of this question. That's the question. Is there?
Is it? So what is it? 115.
Oh yeah. Next one.
118.
118. Removing organic impurities. Yeah?
Yeah, the answer is B.
Yes, the answer is B.
They just see.
No. It is to remove inorganic impurities. That's the purpose of chemistry. Is that thinking? Please, in case they ask you for some. KMNO4 is used to remove inorganic impurities.
There's another one.
Next question.
119.
419. 112. The rate of formation of Z is found to be independent of the concentration of Y. Since it is independent of the concentration of Y, then that means that it is zero order, Abi?
Yes.
But it's quadruple when you double the concentration of X. That means it is second order. It is second order with respect to X and zero order with respect to Y. So the answer is option D. Second order with respect to X, zero order with respect to I. So just note those ones.
Miriam, so don't choose B for 115, not A.
We treat them.
If I say A,
119.
I'll search that.
The soil around
Yes, that's so.
lead is usually used in making battery.
Yes.
So around the areas where they do all these things, you see lead there. Is that taking 124? The volume of oxygen that will remain after reacting 8 cm of hydrogen. That's 8 cm. The answer is 16. Abi? The answer is 16. Next question. Wait, you already know the answer is 16. Is it that you don't know how to go 16? Now, you have 2H2 plus O2 to give 2H2. So now 2:1:2. If this one is 8 and this one is 20, if this one is 20, what should this one be? 40. But it's not 240, so we can't use that. So if this one is 8, this one will be what? 4. So that means if this is 8, this will be 4. So that means we have 0 left.
I should get more than what I got.
16 left. And they say that what's the volume of oxygen that you did not use? So please, all those question 1 to question 1 to like question 100 and something. Let me see. Question 1 to like question. Let me even say to question 60. Even before your exam, you can glance through them again. So they are the inorganic aspects major. But
They're not resistant, but I quit.
just practice. Ọmọ tí ó bá bọ́ wí náà kò sí ọ̀kẹ́ ìṣe. So wàá máa ka ní ọtí tí wàá fi jù. Wàá máa ka ní. And please, you have always begged you that you should not compare yourself. We all do not have the same brain. Yeah, and it's not because we don't have the same brain. Because of the way we grow up. There are a lot of factors that determine what we know. The way we grow up, the environment we grow up, the people we relate with, the school we went to, the type of people that motivate us from beginning, they determine our brain development. So, that's why I always beg you not to compare yourself. If you are reading and you are finding it difficult, just waste your time. You will still pass through that stage. Just continue to work harder. Just work harder. You should not give up on yourself. Just work harder. So, there's nobody that cannot do yet. There's nobody.
Finish.
I'm saying nobody. In this place, that there's anybody here that's your brain. You can't be very smart. There's nobody. But when you don't know it yet now, it's just there are a lot of factors that determine that. It's either you are not well taught in your school, or if you are the type that you don't always read school. When they teach you, you don't read, you don't listen. When your parents tell you to read, you don't do it. Or they did not even teach you. Everybody has issues, one way or the other. So, but work harder, you will get better. So, 2 more questions. Then when we answer your general questions, then we'll leave.
That is the option. So them has not talked about it.
111.
That is the option.
This question came out in my own chat. This same question, 111. 1 mole of hydrocarbon contains 6 grams of hydrogen. If the molecular weight is 54, the hydrocarbon is. Now, they already told you the molecular weight, and it is 54. And it is 1 mole. 1 mole. That means that the mass is equal to the molar mass. The total mass of the hydrocarbon will be equal to the total mass. Now, so if I say 1 mole of the hydrocarbon, number of moles is equal to mass over molar mass. So anytime you hear 1 mole, that means that the mass is equal to molar mass. Do you agree? 1 mole, 1 times 10 will still be there. Shake it. So now they now said there's an hydrocarbon. Hydrocarbon is made up of what? Carbon and hydrogen. That is CH1. They now said that it contains 6 grams of hydrogen. You know that the total mass will be equal to, let's say I want to calculate the molecular mass of this guy. The molecular mass is going to be X, the number of times around C, plus the number of times around H. Now, this will be equal to XC plus YH is going to be equal to 84. The molar mass. The molar mass, which is equal to the mass. But now, you are given something. They said 6 grams of hydrogen. That means that this one is 12. Abby. I want to see if I can calculate the number of them. This is not the mass. Let me calculate the number of mole of this first. Number of mole of hydrogen. You respect each other. That would be 3, Abby. And the mass of hydrogen is 6, Abby. So I can say that mass of carbon. Yes. So if this mass of carbon plus mass of hydrogen 6 can be equal to 54. Do you agree? So mass of carbon can be 54 minus 6. That's what? So now that I know the mass of carbon, I can calculate the number of mole of carbon. So number of mole of carbon is going to be mass of carbon over molar mass of carbon. And that's going to be 48 over. What's the number of mole of hydrogen? 3. Number of mole of carbon. So that means gas is safe. Is that correct?
No.
C for H3. Were we given something else? Where? Oh.
199.
I want to see. 1 mole of hydrogen. Okay. It's going to be 1 hydrogen, not hydrogen gas. That is, I'm assuming that already know that hydrogen is 2. So it's going to be 1. So this will be 6. So this is C for 86. And C for 86 is what?
Alkyne.
Alkyne. Is that alkyne?
Yeah.
4 times 2 minus 2. So this here, H2. So that's that.
199.
I want to answer one more question.
199. 199.
199.
No, 198.
Which of the following is not true of metals?
No, it's 198.
In an electrolysis setup, to protect iron from corrosion. If you want to protect iron from corrosion, the iron is made what? It has to be the cathode. You want to protect it, so you must be depositing something on it. So the anode will be dissolving and be deposited on the cathode. So you make the iron the cathode and you deposit the metal on it. That's why you get it. So that's that. So if you have general questions, you should. 184. 184. 134. When plastics and packaging material are made from kerosene are burnt in the. So what are the likely gases you have? That's hydrogen chloride. Because of chlorine and hydrogen. Those are the likely pollutants you have around the area.
126.
Whose question?
This is the last one.
So the question of battery in the area, I said lead is the answer. Someone said, what if it's lithium and lead? They use lithium to also make battery. But the answer is lead. It is lead that's used to cause lead poisoning. Is that baking? So it's not lithium. So the answer is baking. Lithium is the option. So it is lead you should go for. So aside the class, aside the exam, you go and prepare for your physics tomorrow. So do you have any questions? Do you have aside class or anything? Is there anything that is bothering your mind and you really want to talk about it? You don't want a therapeutic session, right? Yeah? You can't have 4 hours more. They will divide you to batches, either when you get there. You are not given a particular time. Everybody just has to come at a party. What's written on your own? Yeah. So they will divide you to batches. They just want to do their scrolling. So they might even divide you to 4 batches. So the match 1 hour without the life. So you can't do 4 hours. Is there any questions? So please. Your exam is coming. I can see a lot of 200 plus among you. 320 plus, 350 plus. Overall best exam. So please, don't get scared. A lot of you are that they are reading for the bonus ones. Don't worry, I have a video that I will post it specifically for me. I just sat down and I was thinking about it. And I just sent it. It just wanted to so just to meet you. So, but don't be scared. God is the exam and things and everything will be fine. So if there's anything, please always reach out to me. If there's anything you like.
And please know that you spoil. Don't worry. Come and surround me. Just know that you have it because you are not in the book or you want to go and meet Sister Elizabeth. But if me, you know, you go alone. We want to back that. I think I gave you
so much baby, but it is understandable. You are going to university, so use your maturity. God will be with you.